Okay, for 5C, we're solving for time, and I'm just going to do a couple of the examples from the notes together. So when you're solving for time, you're solving for something up in the exponent, and so we're going to have to use logs at the end, but otherwise very similar to what we've been doing. So we know we have this equation, and we're still using y equals a equals x equals, and so if you're starting with $2,000 invested at 7.5% annual interest rate. So this means that, and it's compounded annually. So that means my B value is 100% plus 7.5%. It's not divided up over a certain number of months or quarters or anything. So that is 107.5%. That means that B is 1.075. And then how many years will it take for the money to quadruple? So that means I'm ending with $8,000. And I don't know what X is because I don't know how long it will take. But X is a number of years because it only happens once a year, one time per number of years. Okay, so I know that using this formula, I know that I have 8,000 equals 2,000 times 1.075 to the x. So I'm going to divide by 2,000, which I already know will give me 4. 1.075 to the x. And here's where some people will want to take some sort of root, but since I don't know what x is, I cannot do that. So here's where I am going to convert to log form. So my base is 1.075. So log base 1.075. And I know that the base and the exponent are going to be separated from each other. 1.075 to the x is 4. All right. So then this is what I will put into my calculator because x is alone. So I'm going to go to my Desmos calculator. And I'm going to do log underscore to get that base. And then right arrow to get out of there. And 4. And it says 19.1687 years. So it's going to take... No. 19.1687. 1687. Since it's only compounding annually, that means it's going to take 20 years to actually make it quadruple. Because after 19 years, it will be less than the 8,000. And it's only being calculated once a year. So it's either 19 or 20. At 19 years, it's still less than 8,000. So it's going to take 20 years for that to happen. Okay, another example is what if it's not happening annually? What if it's compounded monthly? Now how long will it take? So I'm again going to say this. All right. I'm starting with $10,000. I'm ending with $25,000. And the interest rate is 6%, but it's compounded monthly. So it's 100% plus 6% divided by 12 months. So that's 100% plus 0.5%. 100.5%. So that means B is 1.005. Okay, now X is a number of years times 12. So 12 months times T number of years. All right, so Y equals A times B to the X. So I have 25,000 equals 10,000 times 1.005 to the 12t. So I'm going to divide by 10,000. And I get 2.5 equals 1.005 to the 12t. Now that I have the power alone, I'm going to convert it to log form. So I log with a base of 1.005. The exponent is over here. It's 2.5. And now to get the actual number of years, I will need to divide by 12, because what this is going to give me is the number of times interest is calculated, because it gives me the x. So to get the actual number of years, I'm going to have to divide by 12. So what I'd like to put into the calculator to get the time in years is log base 1.005 of 2.5, and then I'm going to divide it by 12 months, because that's how many times it happens every year. All right, so I have log base 1.005 of 2.5, and I'm going to do the whole thing divided by 12. So 15.309 years. And 0.309 times 12 gives me like 3.7 months. So 15 years and 3 months. 3.7 months, so 15 years and 4 months. So this is 15.307. Is that the right number? Keep forgetting my numbers. 309 years, 309.6 years, which turns into 15 years, and 309.6 times 12 gives me 3.7 months. So if it's compounded monthly at 15 years and 3 months, it's not going to be enough. So it's 15 years and 4 months. That's how long it takes to get to the 25,000. So I'll zoom out so you can see that. If you didn't put 12t in for x to start with, you would have just said log base 1.005 of 2.5, and you would have gotten 15, no, you would have gotten, if you didn't divide by 12, you would have gotten 183.7. That's how many times interest is calculated. So then if you did that divided by 12, that gives you the 15.309 years. And so 15.309 or 15.31 years is okay, or 15 years and 4 months. Okay, and then I just wanted to also show you if you are compounding continuously, you don't have to worry about years and months because it's happening all the time. But when you do take get the power alone, when you take the log, that is really, I would not have written it this way. I would have written 1.5 equals e to the 0.06t. And then I would have written it as ln of 1.5 equals 0.06t. And so then you can divide both sides by 0.06. So those are the two different ways that you could write it. Ln of 1.5 is like its own thing, and then divided by 0.06, that should still give you 6.76 years. So this one on the left is not an ln, it's a log with a base of e to the 0.06. That's another way to think about it.